Okay, the previous stream, we got 20 minutes in and we realized that our numbering was wrong. So we're still on Glsl Visuals 3, and the stream number is 117, and the day is Saturday. The last stream was 116, and it was PAINT5D Part 48. We're on PAINT5D Part 49, so I'm just making sure that's correct because I was in the middle of kind of like putting a commentary in here, and then I realized that this video ID number was wrong because we had already covered that. So the time of this right here is, we'll just say 42 because we want to be cool. And what we're doing right now is pixload should be included after the D1, D2, and D3. So, if we get this error message, we can read this little comment as to what's going on. And basically, we're creating a file to help further enforce some of the library ordering. So, we don't care about pixload's order in relationship to everything, right? Pixload right here. But we do care about its order in relation to pixname, pixsave, and pixpush. It should come after those things. So previously, we're looking at the code, and we had this thing called pixload, and it turns out that pixload really should have been called pixpush. And so we renamed pixload to pixpush, and now we're going to stub in a pixload system. Right, because pixpush is our pixel pusher that pushes data up to the GPU, whereas pixload is your load save functionality that is interacting with the hard disk. And also, you see how push and load are right next to each other in the chain? That's actually going to make it nice and easy to not accidentally be looking in the wrong spot, because you see push and load, and so if you're looking for load, but you realize that what you really want is push, or you're looking for push, but you realize the thing you really want is load, you'll be able to find it easily, because in the chain of sub-libraries, they're right next to each other. So it is kind of weird that pixload is not right after save, but pixload is after save, right? So pixload does come after save, right? Because you can't really load anything unless you've saved something. Okay, and so we also want a kind of commentary about what's going on here. So this is a lot of code to just do what we really want to do. Because all we really care about here is the relative order of some files, and it gets really, this thing is very verbose, this enforcer file we're writing. So all we really want is, we got a pixname, then we got pixsave, right? So we got pixname, pixsave, and then we got pixpush, pixload, and then the other thing we really care about is the other thing we really care about is there's more we can kind of care about, but for now let's just say tau depot and tau and PAINT5D. Alright, there's more that we care about, but this is the system. You are here, and relative to the system names above and below in the libchan. Right? So the idea is that we want to make sure these are included before pixload, and these are included after pixload, right? And there are other things that are going to come before and after, right? Because there's this big list here. But in terms of the exact ordering, we don't care about the exact ordering of all of this. We don't care that there's... So where pixload currently is, in this libchan, we don't care that all of these things come before and all of these things come after. We really only care about these things coming before and these things coming after, right? So we have there is a conceptual dependency graph, and the dependency graph has to be solved into some type of linear order, right? So this linear order here is just one possible solution for the dependency graph we have between all of our different subsystems. And the reason we have this strict ordering here is because we don't want to do dependency injection, and we also want to know exactly the order that everything is compiled into, so we can have a lot more guarantee as to the final executable state, right? If we use some type of dependency injection method, then if we add one more library with certain dependencies, it could you could kind of have a butterfly effect thing go on where adding just one dependency could drastically change the order in which the dependency graph is solved. So we're not going to do that. Okay, so now that we have this, and I've kind of explained that again, we're going to take this code, and we're going to just cut paste it, and we're going to do the exact same thing again. But this time we're going to do it for the below afters. So below here is the afters, and above befores. Right? So the idea is that we want to kind of name these sections as to like what's going on in the code. And then above here is just going to be afters, so we'll just say above afters. And then we'll make one more section divider right here. Alright. So below we have the befores. Alright, so just make these two sections. And we only care about tau depot and PAINT5D at this point in time. So we're just going to say, so we have lib, and then we have tau depot, and then we have PAINT5D, and we just want this kind of file to help spot check things. We don't care. We don't really care about the precise setup, right? So hold on, let's, since we have befores and afters, why don't we call these B's for before, right? They have to come before. And if lib is not greater than D1, greater than D2, and greater than D3, but these are going to be greater than B1, so these things need to come before, right? So they have to have lower numbers, so lib needs to be greater than all of these, right? Okay. And then right here is, we're going to call these A for after, right? So it needs to be less than the things that comes after, right? So lib comes after these things, so we could say A1 and A2, A1 and A2 for A for after, right? And then we can get rid of this thing here because we only have two things, A1 and A2. And the things we come after are pixload and tau depot. Okay, cool. So now what we can do is we can take the... We had this libchan enforcer file, which is a really long name, but we're going to stick with that kind of naming. Libchan order enforcer, but this is going to be for pixload. Pixload order enforcer. So it's pixload libchan order enforcer. That's all this file is. Really kind of clunky name. And the next thing we want to do is stub in. Well, before we stub this in, we've kind of messed with the order here. So 18, 19, 20, 21, 22. So after 22, we need to go 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Okay, so 14, 15, 16. Okay, we just want to make sure that ordering looks correct. And then... Was it 33 in the previous video? Did we already change this to 33? That kind of has me worried. Did we already do that? Maybe we did. So let's look at libchan, because I know I didn't edit libchan just yet. And yeah, libchan has not been edited. So yeah, we're about to edit this and add one more slot onto here. Before we do that, let's go in here and create the pixload functions. Pixload functions. Loads pixel data from disk. Disk. Pixload is opposite of pixsave, right? So we might want to make a note of that, like pixload functions. We'll call this pixload dot f for functions. Then we'll take this same kind of thing here. I'll copy this. We'll paste this, and pixload data slash structs. We'll call this pixload.d for data. And now that we have these kind of things stubbed in, the other thing we want to do is we want to include this long kind of name here. So full file path to clipboard, really quick. And it's just going to be, you know, we're going to include ./pixload 3 underscores libchan order enforcer for pixload, right? To make sure that whatever order this is included in is a sensible order, right? So just these order enforcers, right? So some people have include guards, I have order enforcers. Okay, so that looks good to me, to where I think we're ready to work on the rest of this. So we're going to add one more thing to here. So we have 33 subsystems total, and that means that this limit has to match right here. And now we just need to look at, let's put this over here on this side really quick so that we can look at pixload, and we can see, hey, that's where pixload is, and the thing that comes before it is this pixpush, right? So when we're looking through here, we know where to stop when we see pixpush. So we can go all the way down here. We see probably pixpush should be like 25, though we did kind of move things around, so maybe not. Pixpush is 25, yeah. So pixpush is 25. So we just want to take this pixpush, and we want to copy it and paste it, and then we want to rename pixpush to pixload. So pixload, because that comes after pixpush. And then we're just going to add 1 to everything. So 25 becomes 26, right? Because pixload is 26. The 26s become 27, right? And we're just going to keep on changing these numbers. And it's not going to be as tedious as sometimes, because this is somewhere near the end of our library chain, right? But we need this. I didn't realize it. So 30 becomes 31, because we're going to add 1. 31 becomes 32. And 32 becomes 33. Okay, cool. So now we're going to go down into the next section and find 25 again. 25 should be pixpush, which it is. We're going to take pixpush and we're going to copy it. We're going to paste it. And then we're going to change pixpush to pixload, right? Once it's changed to pixload, pixload is 26, right? So we have to add 1 to everything again. So 26, and this is the function files now. So it's the exact same thing, except now we're going through the function files instead of the data files, right? So 29. Okay, so that means this needs to be 30 right here. And it is tedious. It is tedious, but like I said, I like the rigidity and ease of being able to follow the code, right? So it's a trade-off, right? So we're losing flexibility, but what we gain is a lack of abstraction and the ease of following the code. Okay. Now that we've messed with libchan top, we should probably open up, I don't know, this libchan bottom. Okay. And libchan bot, we need to look for pixpush, right? So in this list here, we need to look for pixpush. And I feel like things might have actually... Did we shuffle things around more here, or... So here's pixel save, pixel back, GPU data, pix push, and then we just want pix load after pix push, right? So yeah, let's take these two things here, copy them, paste them down here, and now right here, wherever we see pix push, we want pix load, right? So pix load. The reason why pix load comes after pix push is because after we load from disk, we might want to be able to use the pixel pushing functionality to get whatever was loaded from disk onto the GPU. That is why we have that ordering. Okay, so now that we have that, let's look for 25 here. So 25 is this pix push, so let's copy all of this nonsense. Let's paste it, and then let's change 25 to 26, and this pix push becomes pix load. And actually, let's... That wasn't the best way to do it. 22, 23, 24, 25, 26. Sure, why not? Well, it's not a big deal. We can just go like this. Overlap like that. And paste. And this becomes 33, right? So pix push and pix load, 25 and 26. That looks correct. Okay, cool. So now, right here, pix push, we're going to duplicate this. And this one beneath it becomes pix load. And then we're going to take these and move these numbers up. And now we're going to have a 33rd system entry. Excellent. So what's next? So we did the libchad, and we also have to do f macros. So let's go into lib and let's go f macros. So f macros, we got a bottom and a top file. But not only do we have a bottom and a top file, we're going to keep it over on this side so that we can reference the libchan file. But we also have one other thing, which I sometimes forget. In main, we have the functions file where we're going to use f macros. So we need this as well. So let's look at this top file for a second. These numbers here, so 28 and 30, are going to be probably pushed up by 1. So tau depot is probably like 29 now, yep, and tau sync is 31 now. So yeah, these need to be pushed up by 1. So this needs to be 29, this needs to be 29, this needs to be 31, and this needs to be 31. Okay. There's more, but there's more. Is there anything that we think actually needs to be initialized with pix load? And I don't think there is. Now, if we change our mind on that, we can change how this works. We can switch things around, but there's nothing I can think of right off the top of my head that needs initialization. So we're going to add this function name to pix, to the init none section, right? The init none section. So we got pixel push, and then after pix push is pix load. So, and look, I mean, we got pix load here, we got pix save here. So it's a pretty good bet that this is indeed the section that it needs to be in. And we're going to delete all of this code right here. All this code was auto-generated, so we're just going to regenerate all of this code, right? So I'm fairly confident, I've been fairly confident that these indexes are right. Like if these indexes, even though these are on the comments, right? If these comments are not correct, then what I'm about to do could just destroy my code, but I'm fairly certain they are correct, so I can use them like that. And yeah, so now we have regenerated all of these f macros for these different functions. So f macros is just a way to, you see how clunky all of this is? Well, we want to hide some of that clunkiness in the main function file, right? So basically, if the file has not been included, then this f macros initialization none function will cease to exist, right? So init none and a discarded argument, because this macro resolves to nothing if we haven't included this file, right? But if we have included the file, then it actually resolves to the correct function, right? So that's what f macros is for. It's just to help streamline the readability of the main code base, but obviously there's a lot of busy work involved in doing this. So now we got to go in here. We know that it was a init none function, right? And that it came after pix push. So we can find pix push here. we can duplicate pixpush, and then we can rename this to pixload. And then we're good there. So now the next part is we have to go into f macros, or not f macros, but the main function file, and we have to look for where this is coming, where we're using this. So let's look for pixpush, for example, because pixpush comes before pixload. And there it is. So let's just insert, let's duplicate this, pixpush, and this will be pixload, init none, right? It's still in init none, so that's good. And then we can move these numbers up, right? So we can move these numbers up, and now we have 33 here. And P5D OGL is definitely 33, tau depot is 29, so that makes sense. And then we gotta do the same with the actual code. So this is the control F help right here, control F help. So we can actually, if we control F through the code base, we can actually find these actual functions near their call sites, which is right here. It is a bit clunky that way, but it's a compromise. There's no way to write perfect code. So this pixpush right here, we want to duplicate this line. So same deal as last time. Duplicate pixpush. We're going to call this pixload. And then all we're going to do is we're going to take these numbers, these little checksum numbers, and we're going to shift them up, and then we're going to create a 33rd entry. And then we can spot check and say, what about 28? Is 28 tau dirt? 28 is tau dirt. Init none for P5 1 OGL. That looks correct as well. Yeah, so now that we have that, we should be good to go. Or actually, no, we're almost good to go, except for one more thing. In pixload functions, we need an init none function. So paste init none. And the init none function, we don't really care about it, so why not just kind of make this a little bit more terse, right? So we know this is reserved for future use, blah, blah, blah. We've done these init none functions plenty of times. We really don't care. Let's just make it take up less space, because we really don't care. So we'll call this AAC pixload init none, right? And then we're good. So we got the little stubbed in init none function that is a do nothing function. It's just there to declare, hey, this is the way I've explained this before is this is raise your hand if you're not here, right? Like your teacher in school probably joked sometimes to say like raise your hand if you're not here. Well, actually we want our code to actually be able to do something akin to that, right? Where we're going to go through all of the systems and init this system, init this system, init this system, but if the system does not have an initializer, we still want to be able to see it in the list of files we're going through, right? So, you know, we want to init this, but then we don't init these, but we still want them in, like, the roll call, if you will. So let's give this a run and see if this will work, or if we're missing anything, or what's going on here. So, oh, that compiled, so that's nice. So, I mean, if it compiled, we're probably good. Yeah. Okay, cool. So we're not really going to write any pixel loader code right now. It's just that we absolutely do need this here. And when we were looking over the code earlier, we were like, hey, this pixload before we did video 117, pixload was formerly known as pixpush, right? Because pixload just pushed pixels up to the GPU. And then we realized, well, that's going to be kind of confusing because we have this thing called pixsave, and usually you think of it as save and load, right? And so the naming wasn't quite correct. So we took some time to do a little bit of refactoring so the code makes more sense, right? So formerly known as pixload is now called pixpush, and now pixload is just an empty file that we're eventually going to write the complementary code that complements Pixel Saver, right, for loading and saving data to and from disk. Okay, so now that we have that stubbed in, we can figure out how the heck are we going to So I think if I close this tab, do I lose everything? What happens? No, it's not if I close this tab, I lose everything. It's that if I have a tab right here, if this is the only tab and I drag it over to this editor, then this editor will close. Okay, anyways. So how are we going to find the pattern code, right? Well, there's plenty of ways we could find the pattern code. One way I want to try is, well, what happens if we look for P in quotes, right? Because we know that P is for pattern. So if we find all, does it get us where we want to be? And it gets us pretty close. PAINT5D F and PAINT5D data. So let's open up both of those really quick. And I was actually expecting to find it somewhere else. But, yeah, this is for testing. This is the P key right here. This is the P key right here. What we did wrong is we really should have looked for... We looked at the wrong thing. We really want to look for not P in single quotes, but P in single quotes, because we're looking for a character, not a string. And now I bet we're going to find exactly what we're looking for. So case outchar equals P. So this is our key binding, our native key collection kind of code. Key bind is what we really want to look at. And yeah, so we see P5D pattern is hooked into P. P is for pattern. And if we want to see like where that works, we can take P5D pat, and it's a unique enough token that if we just do a find all in files, we can see where it's being used. So paint5d.f. Now, is this a keyboard listener? I guess it's probably a keyboard listener, huh? Yeah, so Paint5D has a lot of stuff in it, right? It has like the math for Paint5D, and then it has the keyboard handler for Paint5D. Like, it has way too much stuff in it, and that's why we kind of separated this into Paint5D, Paint5D 1 OGL. I almost think that we should create another thing called P5D 1 key for like, or P5D input, maybe? Something like that. Because I think that this whole file is just a little bit ridiculous in terms of its size, right? Like, if we look at the amount of code in here, the amount of code in this file is like, you know, a lot of code, right? And it might make sense to say, hey, we should have a keyboard, we should make a keyboard handler section of code rather than just this all being in Paint5D, right? And so we could have a Paint5D system, and then for different sub segments of Paint5D, we can use the shorthand P5D whatever. Yeah, but anyways, I'll figure that out as I go. I need to take a quick break here. So I'll be back. I'm gonna set this to, I guess, 12 minutes. Okay, I'll be back. 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Late weights. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Okay, so break is still going, so I'm going to keep this timer going until break is up here. And then we'll continue with whatever the heck we're doing. Alright, hold on. Bottom screen. Let me see what it's, reading something on Facebook. Wholesome. Okay, anyways. Let's close that. Let's not waste too much time on Facebook here. Let's move this over. And then kind of figure out what the heck we're doing, because okay. So we kind of thought that, you know, PAINT5D has quite a lot of crazy kind of code in it in terms of just P5D, in terms of the key bindings, and there's keyboard input handling, and there's all these other functions. There's a lot of stuff in here. We might think that maybe we should break this into more files, but for now, let's not do that. Let's just try to fixate on what needs to be done. So, the pattern here. So, PAINT5D draw default offset, right? So this thing here. Now, the question is, if we're going to draw a default offset, does it make sense to also have PAINT5D kind of, do we want this command to also push up that data, or do we want to do that as a separate thing? I think that doing it as a separate thing might make more sense. So, you know, after we draw it, right, because we might want to use flat. First of all, flat is better than nested. Also, maybe we want to use a whole bunch of drawing commands, and then after we're done using those drawing commands on the CPU side and we've composited a final image, then we want to actually upload, right? So I think that would be the best decision. So what we're going to do is we're going to say like AAC 2020 pix push, and then pixel push is going to do the pixel pushing to the GPU, right? So we just call it pix push. I don't know. Pix push in the namespace implies the action, right? If we keep everything small with a do one thing and do it well, we don't even have to say, you know, push pixels to PAINT5D, right? We don't have to do something like that. We can actually just say pix push, and I don't know how we're going to say this. Should we say pix push PAINT5D? Or is that kind of confusing, right? Because now it doesn't even look like a function, right? That's the problem there. So I feel like there should be something that kind of says we could do I don't know what we want to do. Pix push. I don't know what we want to do. I don't know what we want to do. Could do PT for push to. This makes it look like a macro or a constant of some sort. That's what bothers me. It's not a namespace, right? We actually want to say, you know, PAINT5. Do you want to pix push to PAINT5D, right? We're gonna do that. Pix push tar for target. PAINT5D. Or pix push target PAINT5D, right? So 1, 2, 3, 4, 5, 6. So Or how about, what is this? Text arg for texture target. 1, 2, 3. The only problem with that is text arg. It looks like text arg rather than texture argument. So text tar for texture target. So hold on. So texture. What is a texture, right? So we know a texture is just an allocation on the GPU, but if we look at the definition. We should look at the definition and be able to kind of figure out if we call it texture target, is there something else we could call it, right? And if we read up a little bit about textures in OpenGL, maybe we can find some more synonyms or verbiage to make this a little bit better of a name than texture target. We learned to add more detail. Prefer to use a texture. A texture is a 2D image. Even 1D or 3D textures exist. Used to add detail to an object. Think of a texture as a piece of paper with a nice blah blah blah. Yeah, so it's just a 2D image. I don't know if that's now. How about texture 2D, T2D target, right? Texture 2D target, right? Or how about that? How about that? That makes it a little bit more terse. So, just the reason why we want this in the middle is just to aesthetically, because if we just don't have anything in the middle, it just looks like a big kind of like, it looks like a macro or something. So, pixpush texture 2D PAINT5D, right? So, I think that's a nice name. And then what we're going to do here is we're going to go into... Well, doesn't Pixel Pusher already have something for this already? Like, aren't we making stuff up by now? So let's go look at Pixpush should already have something for this, right? Pixpush functions. Yeah, because Pixpush already exists. Now, I do like that idea of calling it T2D whatever the heck, because then we can make kind of like these wrapper functions. And I'm going to guess that the current thing we have for... I'm going to guess that the current way we're uploading this is a caller of function should call this. Okay. Okay, so this upload texture thing, what we could do is we could make specific uploads that make this easier, right? We could just make we could make like little nice utility functions for how this needs to work, right? So pixpush upload texture just wraps this upload texture command. But we could kind of like create pixel push for all the different texture allocations. So here we could create you know, void, right? And this could also take void. And what we could do here is we could do like a struct AAC, or struct AAC 2020 GPU data, right? So this kind of struct here. So look at GPU data for a second. So GPU data.d, and it should just be like a, yeah, AAC 2020 GPU data, and it has all these members here. And we could use this struct right here. So AAC 2020 GPU data. We could just call it GPU data, right? So no need to get fancy, right? And this struct, we can zero initialize it, right? So zero initialize it. And then we can just say GPU data. Actually, let's just go GD for GPU data. Or call it DAT for data, right? The reason is that when we search for GPU data, we don't want to like have tons of fill out GPU data instance to push to GPU. Right, so we want to fill this out, and we just want to say dat.cpu picks, CPU picks, and we're just going to fill out everything we can, right? So we have, I don't know everything that matters, but let's just fill out everything we know, right? So we have these things, and then we have, if we have a sampler. So let's just take all this stuff, and let's just take all these names here. Let's just copy paste, right? And just go over here like this and go bam. And we missed something. Okay. And then we can just figure out what goes in here. And then on this side, we can just, you know, we can just comment these out, right? You can just keep some visual space here between these kind of sections, I guess. And this is kind of verbose, but the idea is that now we can put this over here for pix push. And we can fill this out, right? So we're going to go in pix name, because pix name is actually where all the data is stored. And we can start filling this out, right? So for the texture slot, right? So text slot, we can just match things, right? So text slot, oh, it's called PAINT5D text slot. How unique, right? How about the texture handle? Ooh, here's some texture handles. Oh, here's PAINT5D texture handle, right? And we can kind of go through this, and a lot of it's going to be kind of that. So, oh, we have a sampler location, huh? Maybe this thing has these sample locations. So text sam, you see this is called, this thing right here is TS. So it's this guy up here, and it has sampler location and sampler value. So this thing here, we got to do this texture sampler dot sam lock, right, like that. And then this also dot sam sampler value. So the sampler location and the sampler value, right? So these now match. And the has value, well, I don't know what that is, but it's right here. So to know if we've like wired things up yet. Now the width and height is just hard-coded to 512 by 512. It's 512 by 512 pixels. The actual data allocation we need is this guy right here. So we can take this, and then the pix name, we have the pixel names over here, so we can take this thing here, and pix name for the GPU data, is it like a string, or what is it? It's a UO8 pointer, or COC, const char pointer. Okay. And this is an array, which means this is actually just a, it's just a really weird way to make a const char pointer, but to make it exactly, you know, 8 characters. So that should be everything we need to get that working, right? Like this itself is a pointer or an array. So that should all be kind of like what we need to get things working out of the box now. Now the thing I noticed is that despite our best efforts, things got a little bit verbose. So can we kind of like make, instead of calling it DAT, why don't we just call it D? And see if we can shorten that up. Yeah, we can shorten it up until everything is kind of short enough to not have to abbreviate it and just throw it into the code as it is. So you might be looking at this and being like, geez, this is really clunky. Why would you do this? But the idea is that we decided that the GPU data struct is just a temporary struct used to pass around a whole bunch of loose data, right? So we got all this loose data, and the only usage of this GPU data struct is as a container for passing things around. So in object-oriented programming, you'd probably be like, oh no, don't use it for a container to pass things around. Make it the actual container where it actually lives. But I thought about that, and I thought, you know what? I think by making it like this, we get everything to be nice and flat here. And then when we're actually going to pass this around, we have to, since it's only a temporary container, every time we pass it around, we are kind of forced to list out everything that's in there. And it gives us a idea of what's actually going on in the code by just being able to read the code, if that makes sense. Okay, so now that we have this, the next thing I want to do, I think, is just clean this up a bit. So instead of doing, let's actually give this like dash line I2x64. Let's give it like a little dash line like that, and then it's like everything is so close, we might as well just add it like that, right? So that everything's kind of nicely justified up to the right edge there. Might as well. And fill out GPU data container. Alright, so we're just going to fill out the GPU data container right here. That's what's going on here. And that's all that's going on there. That's all we're doing. We're just filling out this container, which seems kind of clunky, but I don't care if it's clunky if I can follow the logic, right? And once we have this, we can just take this helper function here, and we can just say, hey, upload texture, and we just want the address of D, right? And upload texture. Alright, so using container. Alright, so we're going to upload the texture using the container. So we're going to fill out the container, and then we're going to upload the texture using the container. Alright, that's all we got to do. And we can also kind of like, if we can get this working, then we can also do one for Tau Depot, right? To get the hang of how this works, right? Now this is kind of like very clunky to where it's like, oh god, look at how much code we're taking up. But let's don't be afraid that things get really clunky and there ends up being a lot of lines of code. Because what we really care about is just being able to very easily follow what the heck is going on, because we have taken the time to do all of this. Now, I'm not too fond of this thing going on here like this, because there's a little bit of mental indirection where it's kind of tricky to figure this out, right? There's a little bit of mental indirection for that. Now, the reason I did that is because if we call it textsam_sam lock, that is just like, that's ridiculously hard to read. So we kind of did this for aesthetic reasons, right? Like, this container really exists for aesthetic reasons. The idea is that texture sampler, the conceptual texture sampler object itself is composed of a sampler location and a sampler value. That's the only reason we have it like this. It is kind of weird, but we wrote it that way just so that when we think of texture sampler, we know, oh, texture sampler, oh, it has a sampler location and a sampler value. Because otherwise, if we use textsam to mean this, or we use textsam to mean this, I found that led to a lot of confusion. So that's the reason why we do it that way. Okay, so now that we have this text2D push, whatever the heck blah, blah, blah stuff. Let's close this GPU data thing. And yeah, so we're going to pix push right here. So this is the new thing we added. It doesn't take any parameters, right? It takes void. And if that actually works, we'll see the results right away. So let's give that a shot. Hopefully we didn't make any stupid syntax errors, but hopefully any errors that we did make were just stupid and easy to recover from, right? Okay. So now we're over here, and we're going to press the P key, and hopefully... Oh, nice. So nice. Okay. So this has been a long time coming, but now we can see the exact data view in the editor, right? So if we go back to the data, so this needs to be fixed. So look at that. So when we go back, press the P key, that's good, but it's not persisting. Now, I'm gonna guess that somewhere in the code, we decided to load like a test pattern, right? We probably decided to load some type of test pattern so that, we probably decided to load a test pattern just so that as we were developing, we could see something tangible and kind of work with it. But now this test pattern seems to be kind of a nuisance, because now every time we come back to here, our stuff's being erased. And I bet if we press just the 1 key, that wasn't what I expected, but okay. So that is interesting. P. Interesting. If we press P multiple times, nothing. If we go back and forth, it gets erased. Press P, we get that. But if we press 1 twice, we, something weird happens there, doesn't it? So we gotta figure out, well, what the heck is going on with that? So before we go any further, we gotta fix this basic kind of what the heck, right? So, if we go here, we press P, right? Press P, press P. Now if we press P twice, no problems. Press P, press 1, press P, now we have a problem. Now it looks like that actually happens if I just press 1 twice. So if I press 1 again, just stuff gets deleted. So I have no clue what that's about. So we have to figure out what the heck do we do in our code to make that kind of happen, right? And we see there's something in there, right? You see these little dots here. So it could be that maybe we're invoking something. So it looks like the init call count goes up, right? The init call count goes up when we do that. So I'm thinking that something about initializing is doing something weird. I don't know exactly what's going on, but I can see that something's going on here. And so if I do this and press 1, now if I try to press P again, it still seems kind of broken. I don't know, so I don't know what's going on here. But we need to fix that. So I have no clue what that's about. Before we do that, though, I think that this code makes a lot of sense, and I think that while we're here, while it's fresh in our mind, we might as well kind of write the other function, right? The other function for the other subsystem, right? Which is it's pretty simple, right? It's nothing fancy. And you could argue that maybe this goes somewhere else, but it's in pix push. It pushes pixels. Well, it's not just because we got a lot of code in here. Sometimes do one thing and do one thing well covers more than we want it to in terms of lines of code. But we don't want to make up a new namespace just because our code file is getting too long. Because if we do that, then we're just going to end up with problems, I think, if we do that. So anywhere we see PAINT5D, we're just going to call this Tau Depot. Tau Depot. Tau Depot. Tau Depot. Right. So so in pix name, we're going to see what we're doing. So pix name right here has these different allocations, and now we're making an allocation for Tau Depot. Now, really, it would make more sense if this one was at the top, right? Because we want to do everything in order. So we're going to move this back around to the top after we refactor the name. And you might be like, well, this is very repetitive. you could solve this with a template, or you could like auto-generate the code, or you can make some type of macro, right? We can make some type of macro to auto-generate these functions because they're all very similar. Totally get that. But what I find is that if we try to save lines of code or try to make things more terse just because we think it's cleaner, yeah, it'll make it cleaner, but it won't make it easier to understand, right? We want code to be easy to understand, and sometimes the easiest to understand code is actually just ugly as hell, you know? Sometimes that's just the case. So, tau depot, right? So this is the tau depot memory segment. And we're actually going to put this one above the PAINT5D memory segment. And then we're going to just maybe condense this a little bit. We could just do this as well. We could do, push to GPU tau depot, right? So we could also try to like make a little header as well. We could get a little bit too designy with this, but right, we could make like push to GPU tau depot so that we know that right, and we could also add some more spaces until that kind of lines up naturally. And then it doesn't quite line up how we want it to line up, because if we subtract spaces here, then it's a little bit too far back. We could just do this, right? We could do that like that, sure, why not? And then let's just delete some lines here. And just getting way too designy. But the idea is just that I would like to be able to put this as a little, like, all this code is very similar, so I'd like to just have a little comment that has the delta. Right, so this comment is the delta, right? Because if we highlight all these, right, we get PAINT5D. If we highlight this, we get tau depot. Now, I'm going to make a lowercase version of these as well, just so that in my editor, it makes this a little bit easier on me. And I'll show you what I mean by that. I mean, it should be kind of obvious what I mean by that, but in case you don't know what I mean by that, I will show you. So now, if we want to color code these, we can go tau depot, we can go orange, or sorry, cyan and cyan, and we can see tau depot. And if we go here, we can go here and here, we can see, oh, yep, so that all visually checks out correctly, right? So now the next question is, well, what the heck is going on with our code? Why is texture uploading working like it is? There's some type of problem. We kind of know part of the problem, but we don't know all of the problem. So the first thing we want to do is just, we added this new texture upload. Let's make sure that nothing has changed in terms of the functionality. And then let's try to figure out why things are going wrong, right? So in here, right, we got this, and then if we do P for pattern, right? Nice. And then I don't know what this is all about, right? So actually, if we go O for output, we should be able to save this to the output and see if that's actually what it looks like. Is it all black with a few dots? That's kind of weird. But if we open up the mod folder, and we see we got this PAINT5D file, we can actually open that up and say, does it actually look like that? And it doesn't look like that, does it? It looks like this, right? It doesn't. It looks like what I expected it to look like. So what we're going to do here is, just in case, I already uploaded this to the to Imgur. So yeah, it's nice to look at, but let's remove some stuff here, right? So let's delete this stuff. And let's open up the project one more time. So if we... Let's go Windows E here for a second. Windows E. Let's put this on another side. And let's keep this over here on this side, the mod folder stuff here. And let's run the project over here. So we're going to see some new files get generated. And what I'm concerned about is it looks like... So after we do this, it's going to create that file.whatever, I believe, right? Yeah, it's going to create file. Right? It's going to keep a file of a solid color, right? Just to test out that color picker. That's all that is for. And now, if we go over here and we hit P for pattern, right? And then we hit 1 to initialize again, everything kind of blacks out again. I don't know why it's blacked out. But if we hit O for output to save this to disk, then I just saw a file pop up. It's down there, paint5d.png. Let's just close this now. And if we look at paint5d.png, it actually has what I expect in it. But something about pressing those keys twice seems to just nuke the shader code somehow. That's what it seems to be. Right? Because that's... Or maybe it doesn't nuke the shader code because... when we save, we're saving whatever's loaded onto the CPU side texture memory. So it could mean there's not much. There's only one execution path in our Glsl code. So if it's the same Glsl code, which I think it is, because there's no syntax errors happening, then I think that when we push up the texture twice, maybe something gets corrupted on the GPU. I don't know what it is yet, but we're gonna have to observe and think about it. We already know some problems that we could fix, but yeah, and I know that some of this code is a complete mess, so it's gonna be kind of scary to look at. Yeah, so once again, if we press 1 multiple times, weird stuff happens. So the question is, like, why is that happening, right? And we have some console echoing that might be able to give us some hints. So why don't we look at the console? And it looks like it's, like, reinitializing, and when it reinitializes, it nukes some of our stuff. So I'm gonna... So let's see, we got this here, right? We got this thing here. And we press 1, and here we are. And it has a texture sampler, and PAINT5D initialization code is getting called, as far as I'm concerned, right? So if we look at this, okay, now if we press, well, let's do O for output so we can create I just want a little thing to let me know that, oh, I did this key press and I saved some stuff, right? And now, god damn it. So I don't know why my keyboard, my window code sometimes doesn't respond. We're gonna just try to press the 1 key anyways and see what happens. Nope, it doesn't like us. So we're just going to hit Control-C, and we got to figure that out as well, so that sucks. So something about invoking this code more than once, I don't know what's going on there. We got to figure it out, though. So let's write all these tests. Okay, we hit 1. We hit O for output, so we're still here. I'm going to move the mouse just so it doesn't freeze on me. And now we're going to hit the 1 key and see what happens after the KP for this already up-to-date thing. So it goes black, and it says, like, already up-to-date, whatever the heck. So I think what's happening is it's like, I think it's like reinitializing itself, but also like nuking itself. So it's like, when you switch from Paint5D to Paint5D, it's all like, hey, we're already up to date, but it nukes itself, is what I think is happening. So if we go here, from here, and then back to here, right, that's going to work because it's going to reinitialize itself properly. But if we press the one key, if we press the one key once and then press the one key again, what I think happens is it's somehow nuking itself because we pressed a key, and then it's not reinitializing itself because it thinks that it's already on that editor, which is a fine decision, right? So we got to figure out like how that's working and figure out how to fix that, right? So because something's going wrong here. Okay. So we know the basic problem, and now we just got to figure out, like, well, where are we going wrong here? Because I have no clue where we're going wrong. But we're gonna have to figure it out. So first of all, let's close any distractions, right? We're starting off kind of new, and in the init function is really where we want to look, I believe. The initializer, and the initializer is probably a that's probably a mess. This initializer is probably a mess. So this current editor, the current thing we're initializing is PAINT5D. Okay, we are now initializing PAINT5D, right? And we got a vital to do. PAINT5D IOU default brush state. Viewport rectangles. Load initial editor state. Okay. So now, do we have like a public init function that's going to kind of like, say, wrap this maybe? So here's initialize PAINT5D. Then what the heck is this, right? Because this says PAINT5D init right here. So if we are, okay, so here's the already up-to-date thing, right? So it's saying already up-to-date, so we're not going to do this thing here. And something about that is screwing with us. And what is it? I don't know what it is. But yeah, so we do have this like already up-to-date thing that's causing it to so that tells me that when PAINT5D init, this public init function is being called, some other nonsense is going on where so the keyboard handler so this is not where this is being called. Let's find in files again. That's not where we're calling it. Oh, are we using F macros? So let's remove this for a second. Let's remove this. So I think that we want to look for the F macros. And if we look for F macros, so to me, yeah, so, so here's where we're, like, reinitializing stuff, right? Well, here's the PAINT5D init that we're looking for. But it seems to be something else is going wrong, where I don't think it's reinitializing that is causing the problem. I think it's something else about pressing the key twice is causing a problem, and I don't know what it is. Well, we're also gonna like reload the fragment shader as well, right? We're gonna reload the fragment shader, but that doesn't seem to break for anything else, right? So if we look at like this code here for the frag bed, right? I mean, that doesn't seem to do anything. But we also have keyboard input function, huh? Okay, I'm gonna guess. Here's what we're gonna do. We're gonna take a guess and say that, hey, I'm gonna guess that this piece of code does something that I don't like, right? I think that something about this is what's causing our problem. So we're gonna take a guess, and just gonna take a guess, right? And then we're gonna start this up, and we're just gonna try, right? So we're gonna go over to different editors, and we're gonna go here, and now if we press 1 again, oh, so it still blanks out on us. So it's not. So we know it's not the F macros PAINT5D keyboard in, right? So PAINT5D key in was not the imposter. So we don't know what it is, but it looks to me like whatever bug we're trying to find with having to press the 1 key twice and have weird things happen. It's not this function, right? Because we can take this and we can comment it out and we still get the bug, right? So we could look a little bit further and say if there's any other call sites, right? So PAINT5D key in, right? So this is the declaration in main. Here's where we're calling it from, so that, right? So it was not the imposter, right? And yeah, so we are fairly certain that it's not this, and we want to double check one more time, right? So we're going to comment this out and make absolutely sure. Yes, it's not this other keyboard listener thing that's doing it, which is kind of disconcerting because it seems that if that's the case, then it seems like it's the actual initialization function, right? It's the actual, right? So if we look at, this init function for PAINT5D, if the next editor equals 1, so do we think it's not this, but it's something in the other possibility is that something about fragbed does something weird. That's the other thing that could happen, right? So maybe we like maybe fragbed reloads some type of default shade. Yeah, maybe fragbed reloads the shader, and PAINT5D init needs to. Okay, yeah, that could be a thing. Yeah, so if we look at PAINT5D init for a second, I don't know, I have 2 of these open. So this init function seems to be ignored, but I'm going to guess that fragbed probably like does some reloading of its own, and that is screwing things up. So if we look at this PAINT5D init, and so this is the actual initializer, but we're not going to call it if it's already been initialized, right? So I don't think this is actually causing the problem. I think that it's fragbed. I think fragbed probably is doing something stupid. You know, the thing is I don't know what fragbed... Well, fragbed responds to the keys, right? So fragbed will... Well, if you press a certain number key, right, it'll switch to those different shaders, right? So I'm going to guess that fragbed has some type of code in it where it's not quite idempotent, or... Yeah, so let's look at fragbed for a second. So fragbed functions. I'm going to guess something is getting overwritten, right? So when we re-invoke... When we switch to fragbed, it's setting some type of state that we're expecting to be overridden by the PAINT5D stuff, and it's not if we press it twice, where the fragbed code executes, but not the other code. So keyboard in simple character key, and it needs to be between 0 and 9, and if it's a valid key, if it's a valid key, then the shader index loaded. If it's a valid key, then we're going to do this and do this thing here. So this is the private version? Yeah, private version. If it's a valid key, we're going to do this code over here. And I'm going to guess that something about this just modifies some state somehow. So... less than 0, so it's an invalid key. We're going to throw an error. So let's clean some stuff up, right? So some of this is like really basic stuff where it's like we don't need this commentary. We don't need such complicated commentary here, right? So we can just say we copy all this, and then we could say go into our right. While we're here, we might as well clean stuff up, right? So in our documentation, go into our hashtag documentation. We can paste this stuff here, right? This code that we're about to kind of clean up and remove some of the commentary from. And we can just say, we're going to remove this. And we can just say, you know, hashtag fragbed invalid number key, right? So we can just make like we can make a little commentary of what's going on, right? And then we can use this in here to just section this off and say, you know, this was a little bit too commenty, right? Where our comments are kind of cluttering things up, and now we're just going to export all this commentary to here, right? And we can just say, you know, @vid IID and 130 and let's say 20, 13020, and that's not the video ID. The video ID is 117, and this is the time. So 130, how about 130:30? Large comments extracted from this block of code in fragbed.f file, right? So that is what we did, right? So we can, I don't know, make a note of it like that. And then we can go back here and we can look at this and say, okay, 66, and this is video ID 66, so we can remove this commentary now, right? Or actually, no, this commentary is not the same thing. This is 55 minutes and 59 seconds. That's actually a different piece of commentary. How about hashtag private fragbed func assumes valid input. Not assumes, but requires valid input. Right? And then we can go over here, and we can paste this little note in here. But yeah, because what we really want to know is that, hey, this is a private function, and the difference between the private function and the public function is that the private function is not error tolerant, right? If it does not get a valid input, it will crash. So it has, so it doesn't have input sanitization. Instead, it has input failing fast, is what it has. Other people would have a public function that has input sanitization, and then a private function that just does not do any input checks at all, but I want to be kind of more careful about things like that, so this is how we're going to roll, right? So public function will sanitize data, private function will make sure the data is correct and crash if it's not, right? So these asserts, right, 0 to 9, we might want to just, I don't think we need to take up all this room, so why not just kind of like make this a little bit more terse, and then we could also kind of line this up with here, and then or, and just line this assert up with here, right? So we know that, oh, 0 or if 0, if 0, so 0 never gets executed, or this condition, right? Then we're going to be like, hey, you got an invalid kind of key thing here. We're just going to condense this because we don't really care about, we'd rather just not it take up that much space, right? Right, so I kind of like format kind of on a what do you call it? On a case-by-case basis, on a whim. Is valid number key, right? So this is a valid number key. Let's kind of like do a Pythonic kind of indentation there. And also, if we can, I don't think we have enough room to get away with that. It'd be nice if we did, but we don't really have enough room to do that, right? Where we can just kind of like unless we want to define CHR key, right? Then if we do CK and CK like that, we could get it to work, right? And then we could just do this, define CK as CHR key, which is kind of like, that's kind of convoluted. Are we sure we want to do that, right? I don't know. But sure, why not? If that's the way we want to roll, then let's roll that way. Okay, so now we got this CHR key as this thing, and now we can kind of do that like that. Sure, why not? Now we're kind of changing code around, so we might want to be careful about this. AAK read key simple. Do not use callback for this. Do not wire up as callback, right? So blah, blah, blah. Let's make a note. This code should not use callbacks. Right, so this code should not use callbacks. Let's not say that. Let's say fragbed. Right? And then we can take that commentary, right? Because there's all this commentary, and it's like, I don't know what all this commentary means. It's just a whole bunch of visual clutter, as far as I'm concerned. And we just want to take that visual clutter and be like... summarize what's most important with all that stuff. And the most important thing here, I think, to know is that we don't want to use callbacks. The reason we don't want to use callbacks is because it could create some multi-threading problems if we try to do our window on one thread and then our game logic on another thread. And then we can say, right here, we can say hashtag 404 shader not found. Right? And then we can put that over here as well. Right, which that wasn't a serious comment, right? That was just me being kind of cheeky. So let's just kind of put that over here as a little note. Let's not clutter stuff up with, like, little rants, right? So we're going to take all these little rants that we have in our code, and we're gonna extract them out, because we need to figure out this code again. And if the code's littered with too many comments, it can make things very hard to figure out, right? So it's nice to have comments so that you know what you were doing, but sometimes you just want to offboard those comments to a place where, like, you can find them if you want to find them, but they don't, like, clutter things up too much. So before we get too far into here, I've been making some changes. Let's just make sure that we haven't wrecked any of the original functionality, that we still have the functionality that we're expecting. Comment within a comment. So let's look for what we're doing here. So let's look at this, and let's look at this and see where we... oh, this thing, read key simple. So somewhere over here where we pasted some stuff, I'm going to guess it's right here. Yeah, this thing right here. Yeah, because this goes with that, that goes with that. Yeah, that makes sense. Okay. So, yeah, so like I said, there's no such thing as a trivial refactor. We're just trying to extract comments, and we can still cause problems. But I do think it's this fragbed code. I think it's the fragbed code that it's the fragbed itself, which is like the base. The fragbed is the base in which we create the base shader, or the base shader code system that we use for every single subsystem. And I think that it's like reinitializing itself, but the PAINT5D system isn't reinitializing itself. So when we go back and forth like this, fragbed reinitializes and PAINT5D reinitializes, right? So it still works. But if we press 1 twice in a row, fragbed reinitializes, but PAINT5D doesn't. And fragbed must have some type of thing where it's deleting some type of state that we set on top of it with PAINT5D. So if we go back and forth like this, we're fine. But if we do this, we have a problem, right? So I think it's fragbed that's doing this. And we can kind of keep on looking into it a little bit further. So I know that we're going to, like, load a default shader and whatnot, and that shader should actually be the shader we want. But I think that if we load that shader, once we load the shader, we actually have to reset up our uniforms and things, don't we? And fragbed has no knowledge of what the shader code needs to contain in terms of, like, what kind of textures and things are in there. Fragbed is kind of like this basic shader manager, and so it can't rewire up PAINT5D specific things. Okay. So, yeah, I'm fairly certain this is what's going on. So, let's look at this. So, the easiest way would just be to make sure that this also ignores stuff. So... that would be the easiest way. Should reload the shader uniforms. So if it found a shader index, right, which it does, it's going to reload the fragment shader. Yeah, it reloads the fragment shader, and once it's reloaded the fragment shader, then everything gets busted. Yeah, everything's gonna... yeah, this makes perfect sense. So I do see what's going on. It finds the index, should reload the shader uniforms. So right here... if should reload the shader uniforms, if it includes Pix name, right? If it includes Pix name... so it reloads iMouse and etc., but then it doesn't know how to reload. It doesn't know how to reload other things. So if we look at, so let's look at where is fragbed? So fragbed is right here. Fragbed has no concept of the Pix name texture allocations, right? Because it comes before that abstraction. So it has no clue how to rewire. It has no clue how to rewire the system that sits on top of it, right? Yeah, so that's exactly what's happening. It's exactly what's happening. So the way we can solve that, I think the best way to solve that is we just need some type of we need some type of protection from reinitializing. So we see that next editor equals this, and we have some protection where, like... yeah, so let's look at how we kind of protect against reinitialization in here, right? So PAINT5D init, right, the public function. If the dexing thing, the C editor that we're dexing, and C editor right here is down here, so so fragbed does know about C editor, so we can use that. So if next editor equals dex eddy, right? So okay, so this is good. This is kind of the kind of thing we need here. And dex eddy is the current editor. Next eddy is the next editor. And we get the next editor from here, right? So what we want to do here is in fragbed, where we're doing this keyboard handling here, right? This keyboard handling. Right, so we see if it's a valid number key. And that's good. So we see if it's a valid number key. And we have these different things here. So we figure out what key it is, and then should reload uniforms equals 0. And if the index is found, okay, so here's what we're going to do. First of all, we're going to cut this into more pieces. So we need to cut this into recognizing the key that was pressed, and then we want to use the reloading stuff. So we want to separate this into two other things. So this is the private function, right? So fragbed key in simple. So here's what we want. We want something like this. We want like I32 AAC 2020 fragbed key in simple, right? So we want this function here, and then we want the signed character, whatever character key. And then this function needs to call two components, right? So it needs to call key in simple and this nonsense here, valid number key, and this is going to give us we want to be able to get dex found. We want to be able to get dex found, right? So we want to see if we can find the index, right? So dex found is really what we're trying to get out of here. What about this string, though? Don't we have this thing called str? Where's that being called from? So we want to get dex found, and then we also want to get this string here, right? So we want to get dex found, but we also want to get str, right? So so we want to convert this. So what we're doing is we're converting the character key to str and dex found, right? That's what we're doing. So we're taking the input key and we're converting it to str and dex found, or index found. Now the problem is that this is obviously kind of long, right? It's a really long function name. So what we're going to do is we're going to call it kiss for key in simple, right? And to make it kind of more obvious, key in kiss, key in simple. We'll make a little section for this. So we've already kind of done that already. So this might... but here, so we know that we want to pass in chr key. And then what we're going to do is for the, for str, these are output parameters, right? So and str and dex found. Right? So now str is kind of like a, maybe if we're gonna do this, then maybe we want to use something better than that, right? So str is like p1 whatever, so it's really a fragment string, right? It's a string of a str is like a str fragment, right? It's a string. It's a string, but specifically the string is fragment shader code, right? So we might want to call it str fra, right? So I want to call this, like here, I want to call this str fra for string, fragment shader, and index. And the index is specifically the found index, right? So I want to call it like this. Now this does make it longer. And so once again, it's like, man, that's really long. But we know the transformation, right? The character key, we're going to convert it to the string for the fragment shader code, and we're going to convert it to index found, right? And then what we can do is we can just say, this should be like a const char pointer, or some type of char pointer, or const char pointer. Yeah, it's a const char pointer. So it's a pointer to const char, which is not the same thing as a const pointer to const char, right? The pointer can actually be changed, which it obviously is because it's starting off as void here. So yeah, const char pointer. So const char pointer str fra equals, and we can just say void pointer 0. I don't want to get into the specifics of making a typed void pointer. And then the dex found is going to be a negative. Dex found, we've got to make sure that we have the correct type. So dex found, is that signed? Yeah, it's an int32. So let's do, well, first of all, let's kind of start using the correct type defs here. So let's do, ooh, that's kind of worrisome. When did I do that? I think I just kind of, don't worry about that. So, char pointer, int32, dex found. And that'll equal 0 minus 660077, right? Just make some type of trap value. And, right, and we're going to change them via these output parameters, right? Now, let's just comment this out for a bit, because we haven't actually edited the code yet. But we want to make sure that the code still runs, right? We've been kind of mucking around in here. I want to make sure that I haven't done anything catastrophic. Okay, cool. So we're still kind of where we're supposed to be. And what we want to do here is, so we get the char key. So let's try to do this. We'll get back to this. Int32, or actually void, is going to be a helper function. It's going to take all this stuff, and it's going to take the int. It's going to take the so CHR, it's going to take CHR key, right? Not a pointer, because it's actually a character, not a string. And then it's going to take a char pointer. But it's not just going to be a char pointer, it's going to be a char pointer like this. And it's going to be called by ref str fra, like that. And that's just my convention, so I know that we're kind of passing something by reference, right? So I kind of like keep, this is the type, but then I do this star by reference so that I kind of know what the heck I'm doing. And then we want to do an int32 pointer by ref dex foul, like that, right? Okay, cool. And then once we have this, we just want to refactor so that we can get this kind of working in here. So we want to like steal some of the code. We want to steal some of the code from in here. So dex foul and str are determined here. So str equals this thing, and then dex foul. Where's dex foul getting assigned? Dex foul equals 0, and then dex foul, if dex foul is greater than 0, so somehow dex foul equals 1, 2, 3, 4, right? So dex foul and str, they're both being set here. So all of this code, right? All this nice code here is valid num key, all that kind of stuff. Yeah, all that junk can be broken into here. And the only reason, right, we're not breaking functions into smaller functions to make it more manageable in terms of readability. The only reason I do not do that. That is not my thing. I don't think that's a good idea to just break functions into smaller functions for readability. We're breaking it into a smaller function to change the functionality, to like ignore certain big chunks of code, depending on if we're trying to like reinitialize a system that does not need to be reinitialized. That is what we're doing. So we pasted all this code into here. And then what we're going to do is we're going to take, we can take this kind of code here for now. right? We can just... This is kind of like a overall goal, but let's just get this working first. So, now this function here, we just want to paste this in here, right? So, so we can paste this code in here, and maybe make it a little bit more obnoxious so that we know that we kind of pasted this in here. And that represents this big block of code we pasted, right? But in order to get that working, though, we have to make sure that we actually use these things here, right? So, do we have strFra and str or dex found or whatever? So we got dex found, right? But the fragment thing is just called str. That's fine, because then right at the end of here, before we exit this crazy function, return via output parameters, right? So we can return via the output parameters right here. Okay. And we're just going to take these by ref variables. So we have by ref this, by ref that. And we can take those and just be like, hey, we can, if we dereference them and set them equal to str or dexfow, and then this is just str in the code, right? So this is just str in the code, and then this is dexfow in the code, right? Dexfow, right? So that's fine. Now, we could also do our error checking here as well, right? So we could keep all this code the same and do the error checking for these. So we could just say, you know, assert that void pointer 0 is not equal to this. And we can just make a note that, you know, at refs never references are never null. And I know I've typed this before, but I don't know if I've typed it in exactly this way. So let's go look in our hashtag documentation really quick and see if we did that correctly. Or if we haven't commented it, we're just going to make another comment here about what that is. When emulating a C++ pass by reference, the reference pointer can never be null, because a reference can, 1, never be null, never be reassigned. Right, so those are the two things that a reference cannot do, right? So for it to be a reference, it can never be reassigned, and it can never be null, right? And we can make a note of that. So I know we've described this many times before, but let's just kind of do this. So the video ID is 117, and the time is 1 hour, 59 minutes, and let's just call it 60 minutes, or actually no. Well, 59 minutes and 55 seconds. No, let's just call it, let's just call it 60 seconds. 1 hour and 60, no, it's going to put it at 2, isn't it? It's going to put it at 2 like this. Yeah. Okay, so let's describe this for the camera one more time. This timestamp here. References are never null. Means that when we're emulating a C++ pass by reference, the reference pointer can never be null, because a reference can, 1, never be null, and 2, never be reassigned, right? So that's just what this is for. And we just kind of kept this little thing here. Now, I see a mistake. We did an at, right? Because it's kind of a reusable comment that's not just for a specific scenario. And when it's a reusable comment that's not for a very specific scenario, instead of using hashtags, we're going to use these little at symbols here like this. Okay. Okay, so let's close that. And this looks good to me, right? So we made this kind of crazy kind of... So something about this is... Why does this not line up? Is it just my editor? Like, what am I doing wrong here? That is kind of concerning, that it looks like somewhere our bracket balancing went wrong. So here's this function. It takes 1, 2, 3 parameters. We pasted some code in it. We did this nonsense. And then over here, we have this code, which does not seem to... Well, we're going to find out pretty quick, aren't we? Where we forgot. So it seems that we have messed with our bracket balancing somehow. I don't understand how. But if we run this, it's not going to compile if that's the case. And the editor seems to indicate that that's what's going on. We can fix that right now. Let's just define CHR as const char. And then, let's, at the top of the defines for this section, we want to undef that. So, right here, we want to undef CHR for const char. And then we want to change all these things. We got to shuffle everything around, don't we? So this is a complete mess, but okay. So we're going to have to just take all of this stuff, and we're going to have to move it up. And now I question why I have this little divider here, because it's like, this is madness, but the idea is that, you know, we don't want this to be changing all the time, right? We just want to do it once and then be done with it. Okay, so 19, right? So this is going to change to 19. And now let's give this a run and see if the bracket balancing is off or something is weird with the editor. int32, nested functions. Yeah, so something is wrong with our bracket balancing. We kind of knew that, but it's like, what the heck did we do wrong? I don't even see it. Like, I see it in the editor. The editor is like, hey, you screwed up, but I don't see where I screwed up, right? So this is the first kind of thing that seems to be screwed up. Like, it's going past here. Oh, if, so this if shader index loaded thing here is wrong. So, so I don't know. So in fact, I so much don't know what the heck we just broke that we're gonna go to GitHub and look at the other code, the original code, and see what the heck we screwed up over cutting and pasting, right? So like I said, there's no such thing as a trivial refactor. We weren't trying to do anything complicated, but somehow we kind of screwed things up as we were cutting and pasting. So we're just going to look at fragbed here, the old copy really quick, and we're going to see what the heck went wrong. So fragbed functions, and we're just going to put this on another monitor, so I apologize that you're not going to be able to see this, but I'm going to reference it for a second as I'm looking for where we screwed up here. So does Torch Browser not have a Control F function? Really? Oh, I like you so much, Torch Browser, but you can't be that stupid. So let's use Chrome here. I'm gonna use Chrome in another browser because I guess that Torch has forsaken me. Usually, I really like Torch, except it does a few stupid things. But then Chrome also does a few stupid things, like makes my background for all of my web pages black because I have a high contrast setting, as if that I wanted to actually view my everything in high contrast. I want to view the web pages as they were designed to be viewed, and it just edits everything to be high contrast. That's annoying. Okay, so let's do a Control F with Chrome, and Chrome behaves properly. That's nice. So, in our code, so here, somewhere we, int shader index loaded, right? That's fine, that's fine. Is valid num key. So the is valid num key seems to be wrong. So is valid num key does a whole bunch of stuff. But got ya. So is valid num key. It's a valid num key. We kind of like set the dex found and whatnot. Okay, I see. So the first thing is that, we need to wrap this up, right? So, right, so this section right here, this is what is missing from here, is valid num key. And then if that's the case, these declarations, dex found and whatnot, they need to be dex found in the, shader index loaded. We don't even need shader index loaded here, do we? That's going to be in the other code, isn't it? So we got to take shader index loaded right here. And we need to move that. We need to move shader index loaded. We need to move it into the main function. And then this dex found here. Let's get rid of this no-op thing, right? Because we don't actually use it in here. Let's get rid of this no-op here. And then constchar str and dex found, we're gonna we gotta move those outside of this if block, right? So we got this if whatever the heck. So we're gonna put them up here, and dex found is 0. Okay, sure, that makes sense. Yeah, we can keep it as 0. Set traps on return vars, right? So we'll label this section as set traps on return vars. And because that's kind of what we're doing here. Right. So dex found and the string that we're going to return, right? So we need kind of both of those to be set. Sure. Let's not worry too much about the indentation here. But now we have dex foul, and let's color code this. So the string and the dex foul and the oh, I see. So it's in that order. Let's put this at the top like this. Like, if that's the way we want to do it. Or actually, does dex foul make more sense as the first thing? Well, I do string and dex found here. what's the order that makes more sense? I think index and then the string makes more sense. Like this, like the dex found and the string that it applies to. So I think we should move this around like this. I think that makes more sense. Dex, then string. So dex, then string. And now we have this thing here where we kind of have it in the opposite order. But if we want to keep that kind of similar ordering, we can go over here like this and just kind of refactor that a bit. Right, so dex and then string, right? We want to keep this kind of consistent ordering between the dex found and the string. And now let's kind of color code that one more time and see, okay, dex found and string, dex found and string, and just make sure that it's cyan and orange in that order, cyan and orange. And then right here, right, these are lined up, so if we have changed those, whatever they're changed to, we want to reassign them, right? So we want these output parameters to get sent out. And now if we look at this, this kind of lines up. Now I am scared that maybe somewhere in here we got like an extra like extra something or other in here, which I think we do. And I don't know where it is, so I guess we're gonna have to just look at this and be like, if dex foul, else, this if here, if should reload shader uniforms, and then this else. So what the hell is this else here? This else is... Okay, so this else is for the, if the index was found. If dex foul, right? Oh, else if is valid num key, right? So is valid num key, right? So this is valid num key got split up. And this is a private function. It expects the number key to be valid, right? So if it's not a valid number key, else so this is valid num key that we're using down here. We're going to use that error over here, right? So if it's not a valid number key, we're in trouble. Now, if neither case gets selected here, right, like we screwed up this conditional, then it's so let's make these error messages a little bit more unique. So we'll have these little things here, and one FU will stand for right, and then if we have DFU, that will stand for right. Okay, so now that we have that, if it's a valid number key, then we're gonna load the we're gonna be able to get a new string and a dex found, right? And if that's the case, then I don't think we need to know if is valid number key here. I don't think we need to do that. Is valid num key does not get calculated here, right? So we don't even know that, right? But what we do know now is if dex foul, right? So if the index was found, we know that. So we know that much. So this so this kind of junk here, we can remove this. We can remove this scope here, and then all of this code could actually be unindented if we really wanted to. So let's give that a shot. I think that this will actually work, but if it doesn't work, we know that the problem is in our refactor, right? Incompatible pointer type. Oh yeah, so we kind of changed how we were doing this. So we decided that we were deciding that it should be cyan and then orange for everything. Cyan and then orange, so we screwed this up. So let's change this around. So this is just cosmetic, but we want to keep kind of consistent ordering here. Cyan and then orange. And then where we're calling this, we need cyan and orange, right? So where this is being called, we decided that it's going to be converted to right? Right, so dex found first and then str fra second. So we're going to have to take this function name, which we renamed, and we're using it in here, right? So change that, and now we can obviously see that these names are in the wrong order. And we can paste this around to get that kind of working. Right, so, okay, so now let's look at that for a second. We have the index first, then we have the string, right? So index and then string, right? And same thing here, we want to move this around, right? We just want to have very consistent ordering. So the index and then the string. And anywhere we see the colors, we should see cyan and then orange, right? Okay, and then over here, cyan and orange. And same thing, this is cyan and this is the orange thing, but it's just a shorthand variable, right? So if we look at that, that's for this stuff there. That makes sense. Okay, yeah, so I think we got that fixed up, so let's run this again. str, undeclared first use in this function. So as we kind of refactored, we probably have... What do you mean? Const char str is right here. It must be that in here... Okay, yeah, so right here, this string is no longer just str, right? This string is now from this, and we actually gave it a better name called str fra, right? The str of the fragment shader, right? So it identifies the fragment shader string. And... Right, so we're going to say it's the first parameter, and then we also do pass the length of it as well. Like that, and that's fine. Okay, so let's give this another run and hope that we have successfully refactored this code. And we're going to have to do some more refactoring, but hopefully that is correct. And we haven't screwed up anything royally, because I really don't. So, well, this part works so far, so how about this now? Alright, that looks good to me, and if we press it twice, we get the same functionality of it breaking on us. But it still works when you go back and forth like this. If we go press the P key, we see that, right? So that's pretty reliable. But if we ever press 1 twice, we get the problem, right? And we know what's happening there, we know why it's happening, but we just want to compartmentalize this code a little bit more so that we can get this to work, right? So we got this thing that gives us the dex found and the string of the fragment shader. And now we want to have another piece of code for all this junk here, right? So shader index loaded, right? So okay, so the only thing we really want to do is like look at dex found and whatever, and we want to convert it to the shader index loaded, right? There's also this should reload shader uniforms, but I'm just trying to think about the best way to do this. So really, this is reloading some type of shader. This is always kind of like, if we look at this, we reload a shader here if the dex file is greater than 0. If it's less than or equal to 0, we also load a different shader and we load this in, right? And then should reload shader uniforms, we do this stuff. So this is really kind of reloading shader code. So so I don't know, we could call it like AAC 2020 frag bed keyboard simple, right? Key in simple code. And we could say that we want to take dex file and str fra, right? We're going to take dex file and str fra, right? So we can see it here, dex file and str fra. We're going to take these inputs, and then we're going to execute reload. We're going to execute a reload. We're going to execute reload fragment shader. That's what we're doing, right? We're going to take the dex found and str fra, and we're executing shader reload, right? And this is the thing that we want to intercept eventually, right? So this is just okay, this is a ridiculous function name. But, right, so what we're going to do is we're going to take dex found and str frag, and we're going to execute reload fragment shader, right? We're going to execute reload fragment shader, and then we're going to get sil, and we could use it as an output parameter like that. And sil is the shader index loaded. Shader index loaded here. So we could say, oh, is shader index loaded at int? Like, what is it? Is it just a standard int? What do we got here? Int, yeah. So we do int 32 for that. Lost my place because this code is a mess. So int 32 sil equals 0 minus, 999. Make it a trap value. And this is sil equals shader index loaded, right? So this sil right here, that's what we're talking about. So execute reload fragment shader and get the shader index loaded. That's what's going on here. Really big function name, but that's what's going on here. And then we can take this here and we can just say, hey, int 32, or actually we can make this a void thing, right? So this other function was kind of like a void little helper function, and we can say void, right? And then we can supply these parameters again. So how do we do it with this function? Do we kind of still do it on everything like this? So yeah, so let's take this stuff. And we're just, remember, all functions, all they do is they just transform data, right? So that's why I'm kind of writing my functions as this, because I'm just writing it based on what data is being transformed into what other data. So yeah, we're going to take the, we're going to take dex found, but this time dex found is not going to be a by ref, right? So dex found and right? So this and this, we're going to reload the fragment shader, and then we're going to get SIL. And SIL is going to be int 32, and it's going to be a by ref sil, right? So the idea is that it's going to be a it's going to be an output parameter, right? And I just have this lined up here, right? So that we see sil lined up with here. We see the string of the fragment shader, and we see the index found, the dex found. Okay. And now all we want to do is we just want to take all this code right here and all this nonsense. All this nonsense, we just want to take it and right, we want to take it right here, and then we want to say return sil and say shader index loaded, right? That's what sil is. And then over here, we just want to paste that in there. And now we want to change some things around, right? So shader index loaded here is fine, but we're no longer returning it as a parameter, right? We're actually, we can do these asserts, but then this return, we just want to say return via output. All right, so we want to return using an output parameter. And oh boy, this is just a lot of work to get this working. But the thing is we don't just want to hack it together, right? We want to put it together in a way that kind of makes sense to make it, want to make it easier to work with, right? If we do a quick hack on top of the problem to get it working right now, we're just gonna have more trouble later, right? So we got to refactor this in a sensible way. So now we have these asserts, that's fine. And we can also say, at refs are never null. By ref var inputs are never null. Right. And then we just want to assert that void. I know we should have already checked it earlier, but I feel like checking it here is a nice place to check it rather than making more sections. And void pointer 0, assert that void pointer 0 is not equal to the CIL, right? So the CIL is the thing we want to export, right? Or get out of this function, right? So I lost my place again. So this is the function I'm calling, and this is the function that, yeah, okay, this function here. Okay, so this thing, we want to make sure that, you know, that's not, that it's not null. And instead of returning it like this, what we're going to do is we're going to dereference by ref CIL equals, and then shader index loaded, right? So we're going to do that. Okay. And if that works, right, so if all this nonsense works, then let's see where that's being called from, right? This should be called from below. So this is 637 and 756, so it is being called from below. And this is how we're going to populate CIL with an output parameter. And right, so now this main key in simple function, this private version, we've segmented everything into these different kind of pieces that are a little bit, right, we've put all the logic into its own functions, and the reason we've put the logic into its own functions is so now we can write some type of intercepting code that'll say, hey, sometimes we want to ignore this this piece of code if we should not be reloading, right? So let's give this a run, and once this gets a run, then we'll kind of figure out how to rework this code. So char key undeclared, so let's figure out where that's coming from. So so I'm going to guess that this thing also uses char key, right? So if it didn't find the index, right? So if it's less than or equal to 0, so I'm pretty sure that instead of doing that, this is the only place we're using char key. Well, it should be exactly equal to 0, I believe, if dex found, because dex found can actually be 0, right? Like, let's look at this. Dex found can be 0, right? Oh no, it can't be, huh? Well, that sucks. I don't want to make this, because this is already long enough, right? It's already, like, ridiculous enough. So what we could do is we could set dex found equal to 0 if the character key is 0, right? So right here you have all this kind of nonsense here. And bed whatever, bed this, bed that. Right, we have bed 0, 0, but we're not using it. Is that the case? Well, let's clear this for a second. So 0. Bed 0, 0, 0. Is that actually not being used here? Yeah, it's not being used here, so we're gonna cross our fingers and hope that the change that we're about to make doesn't totally destroy us. So we're gonna take this here. We're gonna paste this in here, and then we're gonna say bed 0, 0. And P0, so do we have a P0? So where are these P whatever the heck's coming from? So P0 is this loaded pointer, whatever the heck. And down here, so we want to be careful though. If dexfow is greater than 0, break. So that means that it's going to get set here. So let's do this dex found here. Where's dex found being set? So let's do, so it's an integer, right? So let's make it 0 minus 0 minus 2 must be negative. So let's make this negative. And then the dex found here, instead of greater than 0, we can make it greater than equal to 0. And this string here could stay null, because I don't think we have a loaded pointer for 0, right? Like, if we look at AAC fragbed loaded pointers, and we look at those, and we see what those are, I don't think we have one for the 0. So fragbed, but we might. So let's look at the data. And yeah, we don't have such a thing for that. So we're just gonna say, so we're gonna make this kind of different, right? So we're just gonna say, so P0. Let's just do this. Define P0, and it's just a void pointer, right? So P0 is a void pointer here, right? It's a kind of a special case, but if we look here, we already have bed whatever the heck 0, 0 there. And does that actually have a keybind? It looks like it does have a keybind thing for it. So this could break some things, so we'll have to be careful. But so we got these defines and then undef, so let's undef this. So, you know, undef P0 here. So not an O, but it actually is 0. So that... God, why does O and 0 have to be right next to each other on the keyboard, and then you also call O 0, and then it's... I gotta stop calling O 0. That's what I have to stop doing, because then I won't make these mistakes. So P0 here. And we're only gonna break if dex found is greater than or equal to 0. Dex found is set to negative here. Okay. And then here in this code, if dex found is greater than 0, then we do this stuff. Otherwise, if it's down here like this, then we do this char key thing. But now, instead of this, we can say, we can get rid of this case. Right, so this nonsense here. We can get rid of this, and we can say if 0 equals dex found, right? So we can get rid of the having to supply that key, right? So the character key was probably should have been 0 if this happens. So we can do @vid iid. Let's make a note of when we kind of change this, right? So we just changed this. Let's do @vid iid. And the time is 2 hours, 38 minutes, and let's just do 39 minutes. Okay, now let's explain to the camera what's going on here. So we just refactored this from, originally it was the 0 key equals the char key, now it's 0 equals dex found. The reason for that is character key is only referenced one time in this refactored function, and this function is already getting like really ridiculous in terms of how long it is, so I don't want to have to provide also a character key parameter, so we kind of just changed it around so that dex found can be equal to 0, and if it's equal to 0, we're assuming that the 0 key was pressed, right? And then if the 0 key was pressed, we're going to use the status ready shader. That's the whole idea there. And yeah, so we explained that for the camera. I'm happy with that. We can also kind of make this kind of we can deck this out a little bit. Okay, so now the next thing is, did we handle this correctly? Did we do this correctly? So I think we handled this correctly with this bed 0, 0 here, and we'll find out when we run it, I guess. So let's give this a shot and see if we have successfully refactored it a little bit more, or if we've broken something. Glsl, statement with no effect, unused value. Oh, because we have a double equal, because we're being stupid. So let's go down here. So luckily for us, our compiler was gracious enough to tell us we were being idiotic, and now we can get this working, hopefully, unless we've kind of broke something. So we know it's the 0 key that could be problematic from what we've refactored. So we're going to do everything, and then we're going to press the 0 key and hope that, yeah, so the 0 key is working as expected. Now, the other thing is that we're hoping that if we press, like, arrow keys, or if we press, like, Bs or whatever, if we press any keys down here, we expect nothing weird to happen. And indeed, it looks good. We press other keys besides the number keys, and nothing bad happens. So that's good, because the problem is with that refactor, what I was worrying was if we didn't refactor it correctly, then pressing a letter key could possibly emulate pressing the 0 key if we didn't do that properly. But it looks like we did that properly, so now the next thing is to go to this first shader and be like, hey, does that work? How about we press the P key? Hey, look at that, that looks good. How about we press 1 again? So we still have this problem where when we press 1 twice, so if we press 1 and then 1, that happens. So go to shader 3, 1 and 1, okay? 4, 1 and 1, all right, 8, 1 and 1, right? So if we go twice, stuff's getting wiped out. Now, the reason it's getting wiped out is because we're not reinitializing PAINT5D, but we're initializing you could say the conceptual base class, right? The frag bed is kind of the base class of all of the different editors, and we're reinitializing frag bed, and it's wiping a whole bunch of stateful data, like wiring up our texture samplers and things, and then our code just doesn't work, right? So our code isn't working because the reason our code doesn't work is because the texture samplers are no longer set up, because we reloaded the shader code, but we didn't reload the PAINT5D shader code. We reloaded the fragbed shader code that the PAINT5D shader code is built upon, and now everything is crap, right? So, but now that we've kind of refactored the code, right? And you know, the refactor is kind of messy, right? So it's kind of a mess because we've it's kind of a mess, right? Because we've because we have this thing here, and then this thing here, right? So we have these two little helper functions, right? They're private helper functions. And KIS, we don't want to make a note of what KIS stands for. Key and simple, right? So KIS stands for key and simple. So we might want to make a note here. So KIS equals key and simple, right? And then over here, same deal. You know, KIS equals key and simple. We might want to make a note, right, so this function used to be huge, and now we've kind of broken it into these two other functions. We have not done that to make the code more understandable. We don't break things into smaller functions just to make the code more manageable in terms of understanding. We do it because we want to change some type of behavior. So we can make a note here that, right, we could do, like, right above here, we could just say, you know, KIS equals key and simple, right? So we could just do something like that. It's kind of obnoxious, but we just don't want to forget what the heck this KIS thing stands for, right? Because we've kind of had to make everything very shorthand just to get these function names to fit within our 60 column limit, and so yeah, so it's just a little bit out of hand. But let's give it one more run, and then we're also going to, before we fix the problem, we're going to back it up, right? So, because we're at a good spot where we can back up what we've been doing. Some of this refactoring was a little bit annoying and a little bit more error-prone than we thought, but we got it working, right? So now, so I guess this isn't exactly 512 high like I thought it was, or at least according to this pattern here, it would suggest not. Okay. So let's do a git bash here. And say, git status, git, ooh boy, did we change that many things? Alright, git, add dot. I guess we should have made another commit before we did this, because it looks like we did the pixload refactor and didn't put that in there. But git push, or git commit, fixing, PAINT5D re-init error. And we can make, say, you know, vid IID. So the video integer ID is 0117, right? So we can make a note of the video integer ID in case you want to figure out where that is. And then we could say time is 2 hours, 46 minutes, and 33 seconds. Right? So we can have a little timestamp and know what the video ID is, and that's a pretty good comment now, because now if you really want to know what was going on at that time, you can actually check the video log. So I need to do that more often, but I kind of need to just make that more of a habit. And hopefully as I continue working on this code base, I'll make the linkage to the videos a more and more prominent thing, which I already kind of do, and it does take up a lot of time though. So also, since this is a working commit, we can also push to kanji coder master so that everybody can see it. So anybody viewing the stream can see those changes. Okay, so now that we have this done, we have to think about how are we going to refactor this so that it doesn't reinitialize when we press the same button twice. Well, the first thing is if the index found, if this index found is the index of matches whatever was already loaded, then we just want to ignore. So what I mean for that is, let's go over here for a second, and there is a system for current editor in focus, and if we look at the data. So we don't want to just fix this for PAINT5D, we want to fix this for anything. So, last initialized editor index. So this is the editor in focus, right? Last initialized, oh, this is the current editor, right? So, so this is the what was being initialized. The last thing initialized, the current thing being initialized. So it's actually this editor right here. So this editor, if this editor is, okay, got ya. So, all we want to do is say, you know, oh boy, this sucks. Here's what we're going to do. We're going to say, define, oh boy, that's even going to suck. Okay, so, you know, usually we don't do this, but this is one of those long kind of thing. Usually we do not use fancy macros, but for this we're going to have to get fancy. Define function. We're going to use name, and then we're going to take this thing here, and then we're going to glue it together with n, right? So we're going to take it and we'll just say function. If we have enough room to be kind of more explicit with this, we should, because so not enough room for that, but we could probably call it func name, and that'll probably fit. Yeah, that'll fit. Yeah, so we namespace this out, and then we call a certain function name, right? So right here we'll say undef, right? And then what we can do here is we can say fun, and then call this function name here like that. And we've kind of shortened it a little bit to where we should be able to indent this a bit, right? So if we go like this, we can like indent it like Bam, like that. Nice. So let's just make sure that works. Let's make sure that code works. And that makes the code kind of harder to follow, right? Because now it's like we don't know where that's being used. What's the other thing we could do, right? So do we want to... Alright, this is what we want to do, right? We want to be able to use this. I don't know. We might want to... We just want to write it like this so that we can actually find this here, because this is going to be hard to find, right? Because we're probably gonna look for this, and then we're never gonna find it because we shorthanded it. So we're gonna add these kind of ridiculous comments here, which kind of look crappy, but just so that we can, because this is a very atypical macro, and it could really screw us over. So we're just gonna put this for reference here. And now that we have this, what we can do is we can say, you know, looking at this code, we can say that if the if this index editor is equal to dex found, so if dex found if dex found is not equal to else we're going to do log, and we're going to say, now this is an older system, so I don't know what kind of logging functions we have in here. Hold on, so let's put a breakpoint here and see what kind of logs we have. Info messages, yeah, we have like way too many log kind of thing. Info des, info care, info string. This is like when we were doing things like way, we just got out of hand with this. Let's just not even use a macro, right? Let's just use the actual thing because of how out of hand this got. And we'll just say, you know, fragbed refuses to reload okay. So let's make sure that this is like okay, right? So okay. And let's make a note of what's going on here, right? So 40. PAINT5D does not re-init if PAINT5D is already loaded, which is good unless fragbed, which PAINT5D is built on top of, decides it will re-init. This will wipe the PAINT5D specific setup code that was ran on top of fragbed. Now, I don't know if that quite makes sense, but the idea is that fragbed is kind of like a base class. You could think of it like that, and PAINT5D is built on top of it. So if we switch to the PAINT5D subsystem, and the PAINT5D subsystem says, hey, we're not going to reinitialize, we're not going to reset up, but it's built on top of fragbed, and fragbed decides, hey, we're going to reset up. And so fragbed tears everything down, and when fragbed tears everything down, well, PAINT5D is built on top of fragbed, so that means that PAINT5D also gets torn down, even though we decided that PAINT5D wasn't going to reinitialize itself. So fragbed tears down PAINT5D. PAINT5D already decided not to reinitialize, and therefore we get some problems. So we're going to make a note here of like what happened. Like, so fragbed skip reload to avoid data wipe, right? So AAAC 2020 fragbed info. PAINT5D and others built on top of, and other subsystems that are \n built on top of fragbed do not re-init if we switch from shader index X to shader index because the init would be a waste of time, our conceptual base class fragbed must also abide by this rule to avoid fragbed from tearing down the subsystem Okay, so this is a ridiculous info message. But, I don't know, I just want to make sure that we know what's going on. It might be a little bit overkill, but like I said, we can always remove commentary, but we can't add it in later. after when we're in the moment and we know exactly what we're doing, we can add lots and lots of commentary, and then later we can take it away. But we can't do the opposite, right? We can't come back to this code a year later and add a whole bunch of commentary about what we were thinking a year ago, right? So it's better to be more verbose than less verbose, because we can always trim it down later. So let's give this a run. I know we got like these 2 info messages, then that's kind of ridiculous. If dex found not equal to, sign compare. So I'm going to guess that dex found is like a, so U32. Okay, so that's easy. All we got to do is say that, so we just have to do like a, cast this to U32. Or actually, no, we don't want to do that. Because dex found might be like some type of negative thing, right? So if dex found is not equal to a int32 cast of this, right? We'll just int32 cast this comparison here. Because this is already signed. That'll be a better way to go. Because we want to get more, we'd rather get more information than less, so the range of this value isn't very high. So by making it signed, we're not going to lose any information. Whereas for this value, we know it can be negative sometimes, so if we cast it to unsigned, we're going to lose information. So this is the way we want to change it. Sil undeclared. So let's see where sil is undeclared. So we wrap some code, and when we wrap the code, we kind of screwed some stuff up, right? Return sil. So sil needs to be declared outside of here. And it's going to be this thing. It's going to be this thing until otherwise noted, right? So this is horrible formatting. Let's try something like this. Until otherwise noted, shader index loaded is the current shader in focus. Right. So that's kind of what we're doing here. That's good. Okay. So sil is initialized outside of here. And then if we have find an index for a shader, we can load the new shader and return the new shader index loaded, right? Here, right, with the output parameter. And that gives it overridden, and then we return it here. So that looks good to me. Okay, let's try that out. So I think that will be good. I think this will actually fix that problem that we had if this can compile, right? If it compiles, I'm pretty confident. But we don't know. I mean, there could be some other things. So let's see. We got this going on. We got that going on. So that looks good to me. And I don't see... I'm a little bit concerned because when I... Oh no, when I press 1 multiple times, I'm not seeing any of the problem. What I'm also not seeing is that big honkin' error message that I was expecting to find. So that's kind of concerning. And that might... It could be because we have kind of... we have multiple guards going on here. So this guard here... Yeah, I'm expecting to see this, but I'm not. I think the console is just getting flooded, and that's why we're not seeing it. But let's kind of run this again and kind of see, are we getting the desired behavior? And then if we're getting the desired behavior, I'm not going to worry too much about it. Because it seems to me like we are getting the desired behavior. So if I press the P for pattern, we get this. If I press 1 multiple times, we don't get it to change, right? We still get this little pattern here, right? So that looks good to me, where we don't have any problems anymore. Except we have a little stuck pixel. Looks like a stuck pixel. That might just be a stuck pixel on my monitor. I'm going to put my mouse over it really quick. Yeah, it looks like a stuck pixel on... Oh, it's not a stuck pixel. It's just dust on my monitor making, refracting light to make it look like a stuck pixel. Okay. So, right, we got this little pattern. And, we can press O to output it to the save file. And we can go into our PAINT5D save file, and our PAINT5D save file has that data. Awesome. So that looks good. So that's fixed. I think that's fixed. Now I am kind of concerned as to why can't I see the... Oh, I know I can't see it. So let's go in... It's intentional. So let's close this kind of nonsense, and let's open up silence. Open up silence for a second. So silence.d, I bet fragbed has been silenced, right? So if we look at this, tau type, tau sync, they're on. PAINT5D and stuff, that's not on. Pick save, picks back, those are on. I'm gonna turn these ones off. And I'm gonna turn these off as well. But I'm going to turn fragbed. Fragbed I'm going to turn back on. So, fragbed right here, we're going to turn that on. And now, I bet we're going to see this big honkin' message now. So let's try that and see if we can see that kind of big honkin' message. Okay. So things look a little bit different in the console, but that's fine because we changed what logging messages we wanted to see. And now if we press one more time, yeah, now when we press one more time, we get this long kind of message about what we're doing. And, you know, we get this, you know, fragbed, okay, skip reload to avoid data wipe, and we get this big, huge comment. And that's awesome. That's okay. That's kind of what we wanted. And then if we do P for pattern, we can load that data in there, and we can see it there, and that looks awesome. So awesome. I am happy with that. Let's do a git bash here and say that we solve the fragbed reinit error. So git status, git add dot, git commit dash am, and IID 0117, time is 0308 40, 42 to be cool. Fixed fragbed reinit error. Right, so we fixed the fragbed reinit mistake, and now for the camera, for this timestamp, we fixed the problem of when we press the 1 key twice in a row, PAINT5D system data was just getting wiped, and we're like, why is it airing out? Because we wrote all this code to make sure that PAINT5D doesn't get reinitialized, and it turns out that the underlying system that PAINT5D graphics are built on top of, the fragbed, well, fragbed, every time I pressed the 1 key, was reinitializing itself, so we had to add some guard code to prevent fragbed from reinitializing itself, and so we modified this fragbed key in simple function to do just that, and then we made this big notice function here. Whenever you spam the same number key multiple times in a row, you're going to see this message if fragbed logging is turned on. If you want any more information besides that about what was done, well, you're just going to have to watch, rewind the video, number 117, to see more information. But I'm going to make this commit now. And then we're going to do a git status and a git push. Git push GitHub master. And then after we push to GitHub, we're going to push to GitHub again, but we're going to push to kanji coder. So git push kanji coder master. Okay. So what do we need to do now? Well, I think we we solved kind of a big problem. It took us like 3 hours to solve that problem. Luckily, I think that most of the time it took us to solve that problem was actually writing code and not being like, what the heck is going on? Now, it did take us some time to figure out what was going on, but I think we'd have to review the video to really know for sure, but I think that most of the time we spent fixing this code was dedicated to actually crafting up the solution. The diagnostic part of figuring out exactly where things was going wrong was actually pretty easy. Or it was moderately hard, right? It was a little bit intimidating at first, but then we managed to handle it pretty well. So now that we have this, I think it's a good time to stop and start up a new stream. I'll do like a little push-up break first, but I think that we did a big chunk of code and added kind of a new feature of now it works better, right? New feature is it's more correct than it was before, right? Which I think counts as new functionality as far as I'm concerned. It works better. We wrote a lot of code, it works better. I think that's a good stopping point for this stream, because we can start on a new train of thought for the next stream, and then it also gives me time to do some push-ups and whatever, and get a little bit more exercise. So we're going to start up a new stream maybe in an hour if I feel like it. If I don't feel like it, then it'll be some other day. Today is Saturday. So if I don't do any more streams on Saturday, well, I'm not allowed to work on Sunday. So the next day will be Monday, and that's the coffee day, so that'll be awesome. We'll get a lot of stuff done. So, okay, we're out of here. I might be back.